I'm here with Sanjay Ayagiri of Red Hat for a technical discussion on Natural Language Interaction Protocol, or NLIP. It's an exciting new technology which applies generative AI to transform protocol design. Sanjay is a telecommunications area expert at Red Hat and has played a key role in defining standards such as AMQP.
Hi, thank you very much, Dinesh. It's great to be here.
Can you give a broad overview of NLIP?
Yes, thank you. It's a standards track protocol from ECMA, which is designed to promote interoperability between different LLM systems. And the interesting thing about it is that it uses generative AI itself in order to create a universal protocol. And that gives it a lot of really interesting properties that will help create a universal way for clients to talk to LLMs and agents to talk to each other.
So how exactly does NLIP do that? How does it improve interoperability?
It's useful to think about the history of interoperability. In the early days of networking, every client had its own way of talking to a server. You actually had floppy disks that you would put in the machine and it would become a client that could only talk to a certain type of server. The days of AOL and CompuServe and Prodigy, and they were like these walled gardens of I can only talk to this kind of server. And that limited the usefulness of those kinds of services. Then HTTP came along, and HTTP enabled any client to talk to any server. And all of a sudden, it exploded the productivity. Everyone could just mix and match the information they could get from anywhere and mix it with any information they got anywhere else. And that interoperability is what really drove the wild growth of the web. As we get to this world of AI, we're kind of stuck with what we have with modern API design. And modern API design is very structured. And while that may be good from a programming perspective, it leads to problems in terms of interoperability. If you have to upgrade, even if you have to upgrade a component from the same vendor or the same software, usually it's very difficult to upgrade because it's not compatible. NLIP solves this problem because you have a common format that's actually understandable without needing this very detailed structure. What happens is you're able to have any client talk to any server and get its meaning across.
Thanks, Sanjay. Let me illustrate it by an example. Let's consider a client agent which is trying to register its information to a server registrar. Now, with traditional API design, the registrar will export an API. For example, it will say, you must give me your host that you are running at and the port number. And the structure has to be rigidly enforced by the client on the wire and at the server. In NLIP, what we are doing is we are allowing the client and the server side to have their own interrepresentation. They could store the same information in their own internal private format. And on the wire, they would convert it to natural language text, and each side will be able to convert the natural language text to their own internal representation. LLMs are especially good at that. This can allow interoperability between services with different versions. Here we have the registrar service, and let's say that each register agent has two fields, the identity, the URI, and idempotency. When the agent will register, it will say that I'm a identity A running on this URI, and the registrar will create it. And of course, it doesn't know the idempotency attribute of this agent. It comes back to and will ask the agent, hey, your operations are idempotent or not? Again, in natural language. Now the agent will not know what idempotency is, and it will respond with something like, I don't understand your message, I can't interpret it. And that way the registrar knows that this flag is false. And it can reconfirm, hey, you are A with URI U and do not support idempotency. And the server, the agent can confirm that that is correctly captured. Now, the other example, of course, is that sometimes an agent or registrar may make a mistake when using a LLM to do the conversion, but an interaction also checks that. So agent B goes to registrar and says it's an idempotent service. And let's say for some reason the registrar fails to translate it properly. When it goes and checks back with the agent can basically reconfirm that, hey, I support idempotency, or I am B running on V supporting idempotency. And then the system would effectively be able to get to the right representation on both sides. Natural language on the wire with transformation and a few handshake exchanges of confirmation and reconfirmation allows us to have different sides of communication have completely different structures as they evolve.
One of the other things to notice on that slide is that when that idempotency field or whatever additional field you're adding that got added in the upgrade is not understood, think of what would have happened in a traditional API context. You add that field and the server would just give you an error saying, sorry, I don't understand it, right? And then nothing would work. This happens not just in upgrades. This also happens when vendors try to add proprietary fields to force only their own clients to work. One of the benefits here is to keep protocols open and interoperable and avoid those kinds of issues. The other thing to look at is the fact that even though we're demonstrating a text-based exchange, all of these things support multimedia components as well. We are able to transfer in the protocol different types of information. As you can see, the structure of a message has a type with a format and a subformat, and then the content, and then you can add a label for what the content is. What we've been talking about is the content, but if you've tagged the content with the appropriate format and subformat, you can say whether it's text. And in that case, the intent of the subformat is what language the text is in. If you give it some type of binary data, that could be other types of information, such as images, videos, or other types of sensor data, or perhaps it is other types of opaque binary data. We also have a way to tag specific location data because that is something that we think is of particular importance.
So thank you, Sanjay. Now, can you tell me how the NLIP works with existing protocols and systems?
One of the things we wanted to make sure with NLIP was that built on top of the best practices of existing protocols, and that NLIP itself stayed in the innovation space where we've talked about today. There's a lot of work that's gone on over many decades in building protocols, and we want to leverage all of that work and not try to come up with something totally new. This format that we've talked about today is really at a layer where it sits on top of other protocols that have already solved other problems. We have a binding of NLIP to HTTP, we have a binding of NLIP to WebSockets, and we have a binding of NLIP to AMQP, which is ISO 19464. This allows NLIP to operate in many different types of environments. Obviously, HTTP is what as we've talked about on the web, where you're interoperable with pretty much anything. WebSockets is very useful in terms of certain types of performance when you have that capability available. AMQP is used in very secure enterprise situations and certain cloud situations. Having these capabilities allows you to use the appropriate protocol for the appropriate situation.
Great. Thank you, Sanjay, for this technical overview and introduction to the NLIP.
You're welcome. You can find links for this information in the video.